Hey guys, meteorologist Lindsey Slater here, and your little resident space weather expert. Definitely a lot of people out there that are smarter than me when it comes to this stuff, but I do have a general knowledge of how this activity does work. So right now we're looking at HelioViewer. You can go to HelioViewer. I believe this is on NASA's website. Um, yeah, I just typed it in as HelioViewer and you should be able to find it. So right now we're looking at 4274, 4275. These are some prominent areas on the sun that were facing us, that were facing Earth. And I want to show you, this was on the 9th. We are now on the 11th, right? On the 10th, right there. See that big blob that just burst? We got a big ol' X flare out of this thing. It also, so remember, solar flares do not produce CMEs. Solar flares are flaring events. It's bright. It causes radio blackouts. You can get radiation storms out of it. Sometimes solar energetic particles as well. It can shoot out some solar energetic particles, but we're not looking at this being a CME where you have plasma that shoots out. However, behind that flare, there was actually some plasma, and this created this humongous chain of events where we had three different CMEs heading in our direction. So this is a look at SDO. This is a 131, which is the wavelength we're using. This is best for seeing those flaring regions right here. If I switch it to the 193, or 171, yeah, 171, you can really see those beautiful arcs. Lots of activity. That sun is just lighting up right now. Even though we're on the descending phase of the solar cycle, the sunspots basically migrate toward the center of the sun, basically. And that is when you're getting to the descending phase of the solar cycle. They go towards the center and they actually end up reversing polarity. And in the next cycle, then they switch spots, basically. So that is how the sun kind of works magnetically speaking. But you can really see, I mean, just look at how gorgeous. The fact that we can have data that is this clear, this is incredible. I mean, honestly, I think this is almost as, to me, as beautiful as a weather map. It's kind of like when I look at clouds on visible satellites. It's just phenomenal to see, but to see these arcing regions, I mean, the sun is angry right now. It's quite fascinating. So that's what's going on right now. We do have an R3, which is our strong radio blackout. I can actually go to DRAP. Let me do that right now, DRAP. And this is going to, oops, not sweep. There we go. This shows us where we're getting radio blackout regions, definitely polar directed. And this, when you have them separated like this, is a very good indication of radiation storms and solar energetic particles when you have these double regions like this. This right here, that's your radio blackout, but all this up here, this is where you're having major blackout issues for areas. Looks like a lot of Canada right now dealing with that. And you also do have all of Antarctica. Again, I know there's not a lot of people there, but still, this is a very classic event that does present itself like this when you get both poles. And I believe, if I'm not mistaken, this is due to this is a classic radiation storm signature. And what I know about radiation storms is I want to pull up, where is my Soho? So you see this right here. It shouldn't look like a blizzard. It should be pretty clear with little things flying around. When the sun ejects activity like that, everything just gets shoot up into the atmosphere. So you get this like blizzard effect going on. So that's very good indication that we're dealing with a pretty big radiation storm. And S2, so radiation storms are caused from, again, the solar energetic particles. So again, to recap, you have R3, that is your flare causing radio blackouts. The S is from the solar energetic particles, which gives us the double feature you see here. So the blackout is this, solar energetic particles here. So poleward flights would have to be considered to be navigated around this, as you would likely not be able to get good frequencies because of it. So that's what's going on there. I'm going to close out my HelioViewer. We're done looking at that. That is me talking about, this is what I'm going to post here as my thing for YouTube. This is what we're looking at here. But now we have to look at the CME. So this is like a 1, 2, 3 punch. We got the solar flare, we got energetic particles, and we have plasma. These are like, this is the trifecta, guys. So we had some coronal mass ejections on the 9th and 10th, likely reaching Earth today. I would say this is likely going to reach Earth between 9 p.m. and 2 a.m. That's based on the Enlil product, which is dished out by SWPC and NASA. This is a solar wind product, and if I put it forward in motion, what we're looking for is right here. You're going to see the blast. Here's one. There's one coming out, and then the second one catches up to it and actually breaks up into 3. So the first one will likely prime the Earth's magnetosphere for storming if it's the right polarity. We're waiting for it to hit Discover and ACE, which is a satellite that's out there. And what it does is it tells us, basically stereo A, which is this guy right here, it tells us what is going on, what magnetic field, what type of we look at stuff called flux ropes. I don't want to explain that to you guys right now, but it just helps us figure out if we're going to see auroras, if we're going to see impacts from these space weather issues, if we're going to see radio blackouts, if we're going to see issues with transformers. This is what you need to watch for CMEs for. This is the big issue with CMEs, is the potential of transformer issues, more blackouts. And yes, as a bonus, you can see auroras. So that right there pops up right there. So you see the peak. This is around 19Z on the 10th. So that would be so that's the run time. And I believe if we look here, it'll help me figure out where am I at. So we have right there, we're looking at the potential of this arriving overnight. So it picks up, I would say 9 p.m. to peaking around midnight-ish, and then closing out the rest of the day. So we're looking for that peak in plasma density. So very interesting. Let's go ahead and take a look at some of those other products. So this is one of the coronagraphs from the 10th. You're going to see it, big old blob, and then the SEP event comes right after. Wait for it. Big old pff, and then that's our SEP event. All the blizzard that came after that. That's what we call a halo event. Pff, whole thing, whole sun just it's quite fascinating. And we can actually look at small different CMEs. Here's a CME that happened. This one was on the 7th. And we can look at different ones here. This one is from the 9th. That's one of the bigger ones right there. You see it have double ejection there. We also have the one on the 9th. This was CME number 46. Also, I believe this one was just like a streamer. See that coming out of the sun? It's just really wild. So a lot of different things going on with the sun. Because of this, we do have this G3 watch that we are going to be experiencing as we head into, I would say, tonight into tomorrow. That could bring us the potential of some auroras. So I'm going to keep a close eye on SWIPSy, let you guys know what's going to be happening. But I will be keeping a very close eye on this region. Produced again an X-flare radiation event, produced a solar energetic particle event, and also the potential of that CME that will likely be hitting Earth later today and into tomorrow. So I will have more details on that. You guys can check out everything that I have to talk about, obviously, on this YouTube channel, and I will be posting it on my Facebook page.